Today we're going to look at how to do a t-test using numbers program. But in order to understand what a t-test is and why we're doing it, we first need to actually learn a little bit about what a t-test is. So first, a t-test is a statistical test that helps determine if the means of two populations are significantly different. So I have two populations here. In this particular example, it's two populations of birds, actually, and we're looking at bill length. You can run a t-test on any form, any combination of two populations of things, basically. So if you're comparing and contrasting one thing to another, it gives us a chance to see whether or not the means are statistically different. These are the means down here with our standard deviation. We've graphed this before, and you can see from a graph it's pretty easy to see whether or not these means are actually statistically different. There's very little overlap between the means or the standard deviations, so it's pretty common that we could say that this is going to most likely have statistical difference. However, a t-test gives us an actual probability that the two things are different. In a probability, if p equals 1, then we're actually saying the two sets of data are exactly the same. So the closer that number is to 1, the closer it is to say that the two numbers are actually, the two sets of data are actually identical, probably the same population, or in some cases that there is really no difference between the data, and that more than likely it's completely random, that if the means are even remotely different, that it's completely by random chance. If probability is equal to 0, the two sets of data are not the same. In other words, there's no overlap between the means or the standard deviation, usually totally and completely statistically different. In order to run a t-test, we always need to state our null hypothesis. Our null hypothesis doesn't change no matter what we're running. It's always the same. Null hypothesis is that there is no significant difference between the means. We need a point of exception or rejection within this probability. In biology, this point is usually 5% or 0.05. So in order to accept the null hypothesis that there is no significant difference, the probability needs to be greater than 0.05. To reject it, the probability needs to be less than 0.05, or exactly equal to it. Based upon what we can see here, we can probably tell that this is most likely going to be closer to 0 than 1. So just by my graph, I can say that I'm probably going to reject the null hypothesis. However, we always want to have numbers to actually indicate this. So as a result, P, I'm going to run my t-test now. So P is what we're actually finding in a t-test on numbers. Note that this is different than if you're going to run a t-test by hand. But this number is actually just simply give us the probability. I'm going to insert my function, so function browser. In a t-test here, it's actually a lot more complicated than your first original set. So it's important, it tells you exactly what you need to have. My first set of sample values is this set right here. My second set of sample values is this set here. Since I didn't click on this originally, it's actually added it to it, so I'm going to delete that because I don't want that. We're going to highlight that again by clicking on it so I can fill in those blank. Tails is an indication of whether we want a one-sided graph or a two-sided distribution. Generally we're looking for a two-sided distribution. And the type of t-test is generally an equal sample, although you can run unequal samples, but that's for really another later date. We're going to hit enter, and we're going to give that number 0.0007. We can see that this number is obviously much lower than 0.05, and so we're going to recheck the null. And therefore we can state that our two means are statistically different, and that the two populations are different enough that they are not due to random chance. Thanks for stopping by. Hope this helps. Bye.